Now I want to give you some examples of how to find the equation of a parabola if given some information about the graph. Maybe you're given the graph itself, or just some pieces of information, like here I have the focus and directrix given, or vice versa. Maybe you're given the equation and you want to find all these pieces of information, the vertex and the focus and the directrix and the lattice rectum and all these different features of the graph. Okay, and so either way, whatever's given, the equation or the graph, we should be able to find the other one. And so I'll give you just a bunch of examples here. This first example says find the equation of the parabola described and then graph the parabola by hand. So here I have two important pieces of information, the focus and the directrix. And really everything stems from those, but if I have the vertex instead of one of these, I can make everything else work out as well. And so what I'd like to do is maybe just start by plotting what's already there, what's given. Sometimes that's a nice starting point. And when I start this one out, the focus is at -3, 0. Now I don't know exactly how many units I'm going to need, so I'll just make sure I get enough there. So at -3, 0, I have the focus. I'm going to plot that point, and I'm just going to put an F next to that point, just to designate the focus. And then the directrix is at x equals 3. Well, x equals a number is your vertical line, and it's over here at 3. All right, so there's my directrix. I should straighten that out a little bit. Better? Okay, and then I'll just label that x equals 3. Okay. All right, so that gives me a start. Now, one thing I know about parabolas is that the vertex is halfway between the focus and directrix. So I look at the focus, I got the directrix, there's a 6-unit distance between them, okay? And so one way to find the vertex could be to find the average or the midpoint of that distance. To do that, you can take you can subtract those two values, right? 3 minus -3, subtract final minus initial, and then divide by 2. Sorry, no, you don't subtract them, you add them, you gotta get their average. I'm sorry. I don't know what I'm thinking there. You gotta get the average of the two, -3 and +3. The average is gonna be 0, right? So you add them together, and that will give you 0/2, which is 0. So the average is 0. And that puts the vertex right here at the origin. I'll put a little V next to that. And in fact, actually that's a capital V. And in fact, maybe on the directrix I'll even put a D there so that I don't get confused with the axis of symmetry if I were to sketch that in eventually. Okay, so now I have the vertex. Now I know the vertex is going to be actually on the graph. The focus is not on the parabola, it's inside in the interior. Okay, so now I need to figure out, in order to get the equation, remember we need the value of A for the formula. And we also need the correct formula. Notice, first of all, the vertex being at the origin, since the vertex is at 0, 0, I know that my equation is either going to be x squared equals 4ay, or, oops, I'm going to write this next to it, or it could be y squared equals 4ax, and it depends upon the orientation of the graph, of the parabola. Well, this one, because the directrix is to the right, the focus is to the left, this parabola is going to open to the left. It kind of surrounds the focus, okay? And so because it opens to the left, the linear term is always the term that is surrounded, the variable or the axis that's surrounded by the graph. So if you think of it this way, in the past we've seen y equals x squared is a parabola that opens upward, right? So the linear variable, the one that has a power of 1, is the one kind of being surrounded. It's the direction of the graph that it points. And so if this is a horizontal graph, then I actually want the x to be the linear and the y to be the square. So I'm actually going to go with this second equation. I also know that the a value is negative. This coefficient is going to be negative because the parabola is pointing left. So I'm going to use that one. So I know that y squared equals negative 4ax. All right, that's the structure of the equation that we're going to end up with. Now I just have to find the value for a. Well, the value for a is going to be the distance between the focus and the vertex, which is the same as the vertex to the directrix. That's your a value. And in this case, the a value is equal to 3, right? Because we're plus or minus 3 on either side of the vertex. So if a is equal to 3, then I can plug that in to get my equation. I know I'm centered at the vertex, so I don't have to shift. I don't have to put the h and k in there to shift this. So my equation then, y squared is equal to negative 12x. Right? When I put the 3 in for the a, I get negative 12 there. That's the first answer, right? That is the answer to the first question. What's the equation? Now I've got to get a graph. And I've started to sketch the graph, but it's not real detailed. What I really need is the opening, the width, right? It could be narrower than what I've drawn, or it could be wider. Not really sure yet. And so what I need is more detail on the width of that graph. How do I find that detail? Well, that's where the lattice rectum comes in. That's this opening, the width of the opening across from the focus, okay? So, if you recall, the lattice rectum has an opening, get rid of some of this stuff here, that is equal to plus or minus 2a on either side, right? So the gap here, that's a very poorly drawn brace, there we go. That gap has to be plus 2a and minus 2a, so that the lattice rectum as a whole is 4a units across. The a value being 3. So plus or minus 2a would give us plus or minus 6. So I need to go up 6, down 6 at the level of the focus in order to get the opening at the directrix, okay? Or at the, not directrix, at the lattice rectum. And so I need to go up 6. And over. And that gives me a point at negative 3 comma 6. And then down 6. And over. And that's not very straight. That horizontal, there we go. And down, so we'll call that the point negative 3 comma negative 6. That gives us our second point. And obviously the total distance there is 12 because you go up 6, down 6, add them up. Okay, now that gives us a good opening, and from there we can sketch the graph in pretty accurately, just drawing the curve, starting at the focus and going through each end of the lattice rectum then. Now that's not very symmetrically drawn. This probably should be not curved quite so much. That's better. All right, and that gives us a pretty good graph. So we've got all the details on there. I've got my focus, my vertex, my directrix all labeled on the graph. I've got the 2 endpoints to the lattice rectum labeled on the graph. And I've got the curve connecting those 3 key points.